Solving linear systems by substitution. So this is actually chapter 8. I just forgot to edit this. It's 8.1. In the last chapter, in chapter 7, you looked at solving linear systems by graphing the model. So you'd get two linear equations, meaning two equations that result in kind of straight lines or have a constant increase in their values. And then you'd graph the two equations given, and you'd find the point where they intersect, and that would be your solution. Okay. The next method that we're going to look at is doing it, well, the next couple of methods are doing it algebraically. So by just isolating for a variable and then plugging that equation to the second equation, or that's called substitution. Or there's another method we're going to look at in the next section called elimination, where you can subtract or divide the equations from one another to get one variable isolated. Okay, but for section 8.1, we're gonna do it by substitution. Okay, so we'll jump into that. Let's read this little paragraph here first. So to solve for one variable, for example x, you need one equation. So you've seen this and you've done it since even elementary school in grade 8. You know, the rules for isolating a variable, you always, whatever you do to one side of the equal sign, you have to do the other. The opposite of multiplying is dividing, the opposite of adding, subtracting. And you just move everything to one side and the variable onto the other, and you solve for it. Okay. But what if you have two variables and you need to solve for it? So say you had to solve for x and y. How would you do that? Okay. To solve for two variables, for example, x and y, you need two equations. Okay. A linear system involves two or more equations with common variables. In the following examples of linear systems, you will use two equations involving the same two variables to be able to solve for both variables, i.e. the point of intersection of the two lines. The purpose of substitution method is to solve for one variable in the equation, then substitute for that variable in the other equation, so only one variable remains. Okay. So yeah, to summarize this, substitution is a method where, if you have two equations and you have two unknown variables, you use one equation to solve for, say we had x and y. You solve the first equation for x in terms of y, so x equals 5 plus y. And in the second equation, you can plug wherever there's an x, that y plus 5 there, and then you can fully solve for y. Okay, so you're basically solving one equation and then substituting that into the second equation. So if you have two unknowns and two equations, then you can figure out the solution. Okay. So let's take a look at examples here. So these are kind of filled out, but we'll go through this. So example 1, you have an equation x minus y equals 7, right? I think I have a highlighter here too. Okay, yeah, there we go. And equation 2 is 2x plus 5y equals 21. Okay. So the first step is you're going to solve for one equation. So in terms of either x or y, it doesn't matter which variable you want to solve for, and it doesn't even matter which equation you start for. But the thing about it is that there's usually one method. There's usually a easier way and a harder way to do this, right? So, for example, here, if I wanted to use the second equation to solve for x, I'd have to do minus 5y on this side, minus 5y on this side. Then I have to get rid of the 2, so divide by 2 on both sides. So it's a little bit more work. But if I use the first equation here, you can see it's already isolated. Well, not isolated, but the x has no coefficient. And it's pretty easy to move the y to the right side of the equal sign by just adding plus y here and plus y here, and you're pretty much done. You solved it. So that's what they did here. So you can see equation 1. They just rearranged it by adding plus y here, and what you do on one side, you do plus y there. So x equals y plus 7. Okay. Now you just substitute it for the second equation. So here we have our second equation, 2x plus 5y equals 21. And from the first equation, we have x equals y plus 7. So whenever you see an x in the second equation, you plug in y plus 7. Okay, and you just fill out the rest of the equation here. So this is just equation 2 with a substituted y plus 7 wherever there's an x. Okay, now we have the equation all in terms of y, and you could basically use the algebra and solve for y. So here we'll just do it. So you multiply 2 times y is 2y, 2 times 7 is 14, plus 5y equals 21. And then what do you want to do after that? We want to get all the y's on one side. So 5y plus 2y, collecting like terms, is 7y, minus 14 on the left, minus 14 on the right. And that's what they're doing here. You get 7y equals 7, divide 7 both sides, y equals 1. Okay, once you have y, now we can go to our original equations, and always once you figured out one solution, go back to the original. Don't use the modified equations that we did here, just in case we made a mistake. You go back to either one, and again, the first one seems the easiest to use. So wherever there's a y, we just plug in 1. So x minus 1 equals 7, right? And then you move the 1 over, x equals 1 plus 7, x equals 8. And now we just solved for that point of the two linear systems. The solution is 8, 1 for the point. Okay. So hopefully that kind of makes sense. We'll go through it, the same idea again over here. Okay, so example 2, you got 4x, you got 4x plus 3y equals 7. You also got our second equation, 3x plus y equals -1. So first thing is, it's pretty easy. We're going to use one of the equations and solve for one variable. So this equation here, equation 2, you can see the y is already by itself. So to solve in terms of y, all we need to do is -3x on the left, -3x on the right, and then we'll get y equals -1, -3x, and that's the step that they did right here, right? So they're taking equation 2, and then they solve y equals -3x minus 1. Now you have the solution, right, of y, and basically going to use this and substitute it into the other equation, right? The first one, because we haven't used that one, right? Whenever you use whatever equation you use and you solve for y, for example, you're going to have to use the other equation, plug it in. So 4 times x, you just leave that, plus 3y, and there's a y here. So instead of writing y, we're going to write -3x minus 1, so we have all x's, right? And that's what they do here. So you're using the first equation and just plugging in this y that we solved. And now you can just solve for x. So 4x plus -3 times 3 is 9x. 3 times 1 is -3 equals 7. And then, yeah, so you have that here. And now you just collect like terms. And then you'll have -5x equals 10, right? Because you're just, just doing the basic algebra. -5x divided by 5 equals 10 over divided by -5. To get, basically we're here, we're just trying to get rid of the -5 off the x. And x equals -2. Okay, so once you have x equals -2, right? Now we're just going to substitute this value again, not into one of these modified equations, but the original equation. You just plug it in, and you can solve for y. Okay, so here they chose to do, well, they're showing you both methods. You can either use either or. So here they're using the, which equation is this? Y equals -3 times, oh, they're using a modified version of the first equation. So again, to try not to use a modified, just plug into the original one right up here, just in case you made a mistake here. So x equals -2. So just plug it into here, for example. So 4 times -2 plus 3y equals 7, and then just solve for y, right? So that's all you need to do. So again, first step is use either equation and solve for either x or y, right? And then substitute that value. You'll have something like y equals x plus 5, and then use substitute it into the equation you didn't use, and you solve for x, and then once you know like x is 5, for example, and you plug into the original equation, and you get y. So a couple steps to it. Okay. Once you do it a few times, it's pretty straightforward. Here's some practice questions. So if you want to test it out, you can try doing these two equations, and the steps are all written here. And there's more than one way to get the right answer here. Again, it depends on which equation you use. So you can follow along. If you did different steps, that's fine as well. Okay. Okay. So here, all we did was we were substituting. Now in this section, let's see what they do here in part B. Simplify each system and solve by substitution. Okay, so this is exactly the same step as we did before, but now they just want us to simplify it. So we get these two longer equations, right? We got an equation here, and we got our equation over here as well. So before we start substituting, because if you substitute right now, we solve for one equation, say we solve for y here and plugged it into here, we get a really long equation. It still work. It's just going to be really long and take a bit more time. So it's to speed up the process and make it more simple, simplify both equations. So 3 right here, we're looking at equation 1. So 3 times x is going to be 3x. 3 times 5 is 15. -2 times y, -2y. -2 times -1 is +2 equals 6. Okay, now collect the like terms here. So you got 3x, -2y, then 15 and 2 go together is 17 equals 6. Move 17 on both sides. You got 3x minus 2y equals -11. So you can see all they did was simplify this equation to this one over here. Okay. Now in the second part here, what they're doing is now they're simplifying this equation. So before we start, again, multiply the 4 in. They just rewrote it here. So 4 times y is 4y. 4 times 3 is 12. Then you get x plus 4y plus 12 equals 13. Move the 12 over. Negative 12, negative 12. You get x plus 4y equals 1. And now they're, once they simplified it, right? So they simplified this equation to this. Now they're just going to solve for x in terms of y. So x minus 4 minus 4. So x equals 1 minus 4y. Okay. So now they solved this equation in terms of x after simplifying it, and you just you plug this in, and again plug it in. Now plug it into the simplified one right here. You could plug it in again. You could use this equation and plug it into the original here. The only reason we're not doing the original, even though I told you previously you should always do the original, because what if you made a mistake here? It's because it just save you a lot of time here instead of having to do all the algebra over again. So x equals minus 4y, and you just plug it in over here, right? So you can see where there's an x, so writing 3 times x, we're writing 3 times 1 minus 4y, right? And then minus 2y equals 11. Okay, and I'm not going to go through the algebra. It's kind of just the basic, adding is the opposite of subtracting, multiplying is the opposite of dividing, and just isolating one variable. Y equals 1, and once you have this, you can just plug it into either equation that you created. Right here we have x equals minus 4, x equals 1 minus 4y, plug in 1 here, x equals negative 3. Okay, so we got our two answers, and that's our point. Okay, so let's just go through the last example here, because we still have some time. It's only been 12 minutes in the section. So in here, you got our two long equations. So first thing you want to do is check if you can simplify it to make your life a little bit easier, and you can. So we're going to simplify them one at a time. So we'll simplify the first one here. So you got equation 1. So just multiply the 2 into the brackets. So 2 times x is 2x. 2 times negative 1 is negative 2. And same thing here. There's an invisible negative 1 here if you just have a minus here. So negative 1 times y gives you negative y. Negative 1 times negative 7 gives you positive 7, and leave the 13. Right? So we're over here right now. So at this point, now you're just going to collect like terms. So you got 2x, you got positive 7 with negative 2, so it's positive 5. You got negative y, and you have 13 here. Move the 5 over. Okay, 5 is onto the other side. You get 2x minus y. And now we can also just, well, here they're moving y to the other side, but you didn't really necessarily need to do this step, but they moved it over, so you can see that now they have y on one side, x onto the other, 2x minus y here. Okay, so they might plug this whole equation into the substitution step, but before you do that, you want to simplify the second equation here. So it's equation 2, right? And then here we're simplifying it. So 4 times x, 4x, 4 times 2, 8, 3 times y, 3y, 3 times 1 is 3, equals 37. Move just the numbers to one side, and then leave the coefficients on one side. That's what they're doing here. And then, okay, so once they basically simplify it to this equation, okay. So they simplified the equation 2 down, and then equation 1, remember they went a step further and moved the y on one side. So I guess this is the furthest you can go here, right? You can't really do much more. But now this is a substitution step. So we can take equation 1 and plug it in to equation 2. So you have your 4x, right, plus 3 times y. But instead of writing y, we're going to substitute this because y is equal to 2x minus 8, right? So that's what they plugged it in there. It equals 26. So 4 times x plus 3 times 2x gives you 6x. 3 times negative 8 gives you negative 24 equals 26. And solve for x, and you'll get x equals 5. Okay, so we have x equals 5. Now it's easy. Now you can either plug it to the original ones, or you can plug it into the simplified one that we have. So 5, right here, we can plug it into this one even. So 2 times 5 is 10. 10 minus 8 will give you 2. And that's kind of what they did over here, right? Y equals 2x minus 8, and then just plugged in the 5 that we got earlier. Okay, hopefully the substitution kind of works. Again, steps: simplify, and then solve. Step 2, once you've simplified both equations that are given, then solve for one variable in terms of the other. So in this xy example, solve for x in terms of y. And then step 3, once you have x in terms of y, substitute that into either the original equation or the simplified equation to solve for y. and you have your y. You just plug that in to solve for your x in either equation. So a few steps there. Once you do it a few times in the homework, then it'll make sense. Okay. All right, so take a look at the notes, take a look at the homework, and then when you're done, move on to 8.2, which is solving algebraically or solving linear systems by elimination.